क्या है मेरे तेरे दो 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 तीन ग्राहक है उसमें तेरे अनबन होती रहती क्या है तू क्या ग्राहक लगता है क्या हो गया और देखे ना तो बिस्कुट एक दो तो मेरे भी महंगाई निकले थे महंगाया हुआ खुला हुआ नहीं लाया खुला हुआ तो देख के नहीं दी थी क्या देख के दिए खुला हुआ कैसे छेद था कि क्या था हाँ कुछ भी नहीं खोल दिया क्या बोले खुला हुआ एकदम खोल के लाके दी तो बोली क्या वो खोल के लाके नहीं खुला हुआ दे दिया आंटी जी हम कह रहे देख के तो दियो मैं मन एक ऐसे ऐसे किए तो टूटा हुआ था वो नहीं दिए फिर दूसरा से देख के दिए हमने तो ऐसा कौन सा बिस्कुट टूटा हुआ पेपर पड़ा है हैं ऐसा कौन सा बिस्कुट अपने में टूटा हुआ ही पड़ा है एक वो है जो अंदर ऐसे दवा पड़ के टूटल भी जगह अपना लेकिन खुला हुआ नहीं रहता बिस्कुट समझ में ला चूहा खा गया जो अलग बात है क्या ही बोल रहे हैं दो तीन तो ग्राहक तो उसमें भी तो तू चले है ना बेटा चार ऐसे नहीं करना ना और वो छोड़ा कर लेना स्टार पर से ले वो ले ले 5 स्टार ले तो मुझे हल्की खोल किया काहे की पतला खोल के उसे निकाल के पतला कर लीजिए देखो पतला है पतला है वो तो गलत है वो तो भाई तो उसके बाद वो बच्चा है वो बच्चे 10 बार बोल दे तो बात है ना आप समझाने नहीं है आप तो ये बोलते हैं अरे आए कुछ जाओ भाई बाहर वो तो ना बेचारा बच्चा है उसको बोल दिया वो तो कोई दिक्कत नहीं है वो था उसको थोड़ी रिटर्न थोड़ी मांगेगा बेटा ये देख के अभी दिए थे तो तेरे से खुल गया भूल गया नहीं वो क्या बोला पतला है तो उसको बोलना था कि ऐसे ही आता है बोलने का अलग अलग होता है हमारा कुछ कह लिया ऐसे ही आता है अरे बेटा कंपनी से ना है ऐसे ही नहीं सब नहीं ना ऐसा है कि ना ये ऐसा है तो वो ऐसा है कि क्या कर रहे तू अभी लेना तो देख के लेना उसका ऐसा कुछ नहीं होता वो तो ठीक है लेकिन वो खुला वाला तो खुला जैसे बिस्कुट खुला है तो अब बिस्कुट अब कौन सा ऐसा बिस्कुट है जो अपना चुराए चुराए भी रह रहा है कि ऐसा भी है तो उसको बिस्कुट को ढंग से रखो और क्या पागल ढंग से ही रखा ले खोखा में रखा या खोल के नहीं एक दो तो मेरे को क्रैक जेक वाले भी बिस्कुट है ना मेरे को उस टाइम मैंने भी नहीं किया हल्के से वो उसमें से लगता है कि चूहे ने कतर दिया हल्का सा चूहे ने कतरा हुआ है ना ऐसे तो चूहे भी नहीं कतरा हुआ है हल्का हल्का सा छेद भी उसको तोड़े तो पट दबा टूटा
This conference will now be recorded.
क्या बोल सकते हैं रात को चूहा तो आता ही है वो
Yeah, very good morning to everyone. So, in the last 2 or 3 sessions, we started with the controllers, like interrupt controller. Today we will be starting with the SPI controller. Can you imagine what is the use of the interrupt controller?
अरे सुरेंद्र गुप्ता नहीं
What is the interrupt controller?
डॉक्टर के पास जाना पड़ेगा इसके इलाज के लिए
Interrupt controller job is to get the attention of what? Master or a processor. Okay. Why it needs the attention of the master or a processor? Because slave can't directly transmit the data to the processor, so that the interrupt controller is the interface between the slave and the master. it collects all the interrupts from the peripheral devices, and then in the priority register, it will keep according to the priority. Then that will be giving to processor to be served, to be serviced. Correct. So we understand the process of what is the interrupt controller, what is the use of the interrupt controller, how to model the interrupt controller. We understand in the last 2 or 3 sessions, we understand that. So today we will start with the SPI. So what is SPI? SPI is nothing but serial peripheral interface. Serial peripheral interface. So what is the use of this serial peripheral interface? Where we can use this serial peripheral interface?
खेलता ही है ना, कौन देखा बातें जाके वहां बातें बैठ जाता
What is the use of this? Name implies serial peripheral interface. What is the use of this serial peripheral interface? Serial. Data transformation will be taken place in the serial. Okay. Let us take a scenario. Let us take this one. Let me explain very simple analogy of this. What is this serial peripheral interface? This is my processor. The processor data communication will be happen through the protocols. Let us take APP protocol, which is low performance, okay, low cost, low performance, low cost protocol. So this is a processor. Inside the processor, what protocol I have is EBP protocol. This is, let us take, this is a master. Master is a processor, and this is nothing but a slave. Let us, the slave is some sort of sensor. Let us take, this is a sensor. Sensor is directly can't communicate with the what? Processor, master or a processor. The data cannot be transferred to the what? Directly to the processor. So there is an interface is named. Serial peripheral interface is named, where in the processor, the data process can be happen in the what? Parallel. Parallel processing will be happen in the processor. Parallel data. You understand? Now, what is the job of this serial peripheral interface is nothing but it takes the parallel input. It takes the parallel input. And this parallel input is given to the what? Converted into a serial. So this serial input is given to the what? Slave. Okay. And also, it takes the serial input from the where? Serial input from the where? Slave or a sensor. And this will be converted into the parallel. So that is giving to the what? Processor. In simple analogy of where you can use the SPI. So that SPI is an interface converting the parallel data into the what? Serial data. Communication from processor to the like sensor, it is converting parallel to the what? Serial. And if I want to communicate serial slave to the processor master, what happens here? Serial to the parallel. Simply I can call here data conversion is required. What data conversion is? Parallel to serial. Serial to the parallel. Let us take one more analogy. In your pen drive, when you are inside the pen drive, what is the use of the pen drive? Data transfer from your laptop to the pen drive or pen drive to the laptop. Read data, write data. Correct. What happens if I am doing the parallel connection from the without this SPI? If I'm using here as a pen drive, if I connect this, I need what process is required. This process is taken place what? Parallel process, right? If I connect the pen drive to this, then there will be what? Without this SPI, how data will be transferred? It's like a parallel communication. If it is having 100 ports, my processor is having 100 ports. To do the parallel data transfer. Even my pen drive also having how many ports? 100 ports. Imagine what is the size of the pen drive number of ports I should use for the pen drive. There's a limitation of the ports, right? So ports requirement for the pen drive increases. So what we'll do is nothing but to cut down these ports. USB ports, there are 4 main ports we are using in the USB. If I want to do parallel transmission, parallel data copy, if I want to do, my pen drive ports will be also what? Increases. So to address this problem, what we'll do, we'll put a SPA, serial peripheral interface, between your processor and the slave, or a master and the slave. What it will do, it will take the parallel data from the processor. Okay, and then it gives serial data to the what? Slave. Again, from slave to the processor is nothing but it takes the what? Serial data and convert this into the what? Parallel. It is some sort of data conversions, parallel to the serial and serial to the parallel. With this analogy, now we'll go deep into the what? What is a serial peripheral interface? How do you understand? Is it clear this terminology, what I said? Okay. Now let us go with what is the SPA. What is the SPA? SPA is what? Serial peripheral interface. Like how we exactly understand, like the interrupt controller. So we'll understand what is SPA controller, the overview of SPA controller. Okay, what is SPA protocol? Protocol is nothing but what? What do you mean by protocol? That are guidelines. So it is going to give some guidelines to perform the specific operation. So we'll understand what is SPA protocol. Why do we need SPA controller? Okay, so that means SPA controller means what? SPA master. What external blocks SPA controller interface with? Okay, what are the external blocks where my SPA controller will be interfacing with? And SPA control detail functionality. So we'll understand the SPA control architecture and like many things. How many interfaces and ports required with the direction, input, output, in output, then whether registers are required, whether memories are required, whether does design requires any parameters. So is this combinational or sequential? If it is sequential, how many process there is in the design? How many always blocks you can use to model this? Does processor requires any state machine? How many states are there? And what is the significance of the each state? And then implementation style for the what? State machine, and implement the code. Then we'll list down the coding algorithm. So this is what we're going to see first. Correct. What is SPA protocol? SPA protocol, let us take an analogy. So city away, temperature, humidity, pollution, display boards. Okay, there will be each 2 kilometers or 3 kilometers. So we'll be installing all these display boards. What is the temperature? What is the pollution? What is the humidity? And then display boards will be displayed for 10 kilometers or 15 kilometers in the cities. So these systems have a sensors, right? Suppose if I want to measure the temperature, how it is measuring the temperature? Using temperature sensor. The job of the temperature sensor is to convert the heat energy into the what? Electrical. In turn, will convert it into what? That is electrical means what? Analog signal. So we'll do conversion to the digital and we'll do the various process. Correct. So these systems have a sensors which gives the data. Let us understand data which is giving as a number. Okay, to the microcontroller. So which in turn displays the what? Information. That sensor will give the data in terms of number that is given to the microcontroller. The microcontroller will what? Displays the what is the temperature. So we need to connect the sensor with the what? Microcontroller in that case. Correct. So what is the right protocol for this requirement you can do? Then if you understand the analogy of SPA protocol, converting parallel data to serial and serial data to the parallel. Master to slave is parallel to serial. Slave to master means serial to the parallel. So to connect this sensor with the microcontroller, what is the right protocol for this requirement? What is the right protocol? You understand, temperature will be continuously monitored. No, right? You will monitor at 10 o'clock. And next, after 1 hour, you will monitor. After 1 hour, you will monitor. Is it clear? So here, which is the right protocol for this requirement is, we can't use the ABP protocol because this is a peripheral connection. Correct? ABP is what connection it is? Peripheral connection. So which protocol can be used for the sensor which giving the data to the what? Microcontroller. So you can't directly connect the sensor to the what? Microcontroller. You need what? Some interface. To do this interface, what type of protocol we can use? Which protocol can be used for sensor giving data to the microcontroller? So when you talk about the protocol, you know that low performance protocol and high performance protocol. So you know that any three requirements is there. Any two, if you want, one should be compromised. That we understand. So whether we go for the high performance or low performance? Low performance. Why low performance? The data transmission is required what? Less speed. Correct. I'm not copying the data like 1 second, 1 GB data, 2 GB data. Correct. Hourly, once I'm measuring the what? Temperature sensor, that data is given to the what? Processor or a microcontroller. Correct. So the current scenario, if you understand, performance is not a matter. So I need a low performance. I want a low power consumption protocol, and my priority is nothing but what? Low price. Okay. So that in this scenario, performance is not important. Why? Because microcontroller requires the information once at every 10 seconds. Let us understand. Instead of 1 hour, you can understand that 10 seconds temperature I want to monitor. Each 10 seconds. Or if you analogy for 1 hour also, no issues. Correct. So microcontroller requires this information once in every 10 seconds. Temperature is in the range of 10 to 50 centigrade. So it requires only 6 bits. So it requires 6 bits per second. There is a 36 bits per what? Per minute. So needs to be transferred. So how much data I'm transferring it is? Only 6 bits per how many seconds? 10 seconds. If I talk about the minute, 36 bits per minute needs to be transferred. So if you compare this with the USB protocol, so which transfer the data of what? Gigabits per minute. Gigabits per minute. Now for this, to model this SPI protocol, whether you need a high performance protocol or low performance protocol. Low performance. Because, why? Because this is the factor. Data transmission per second, low data transmission, not high data transmission. Because my requirement is like that, correct? I don't want to use the USB protocol here. I don't have that much of high performance protocol is not required for me. So I want low performance, what? Low power consumption, and then low cost. You to understand? So that to interface this, what protocol I need? Low performance protocol. So what is my priority in this case is nothing but reducing the what? Cost, reducing the power consumption is a priority. Why? Because if you take a city of Bangalore, we may need to install the what? Let us take 10,000 such systems. So if I go with the low performance, it costs around 200 rupees. Correct. So that I can reduce the cost. And if I'm in place of low performance protocol, if I'm using high performance protocol that costs 500, so that I can increase the cost. Did you understand? So this, to do this, sensors are connecting to the microcontroller to measure the temperature and etc. I need a low performance protocols. I don't want what? High performance protocols. Is it clear? So mainly I can reduce the cost, I can reduce the power consumption. This is my priority. So hence choosing a protocol which gives the what? Low performance, low cost and the low power. So that for the SPI protocol is the ideal fit for this requirement. Did you understand? SPI protocol is ideal fit for this requirement. By using the USB protocol for the sensor connection to the microcontroller, cost and power consumption increases because USB protocol what? Cost is more than what? SPI protocol, it is high speed protocol. So that I can use the what? SPI protocol is ideal fit for this requirement. Did you understand? So what protocol I can use for this case is nothing but low performance like SPI protocol. Are you understand? Now let us see what is the serial peripheral interface. The serial peripheral interface is nothing but it is a serial means what? Data is transmitted in the serial manner. Peripheral means the data is transmitted at the what? Chip boundary. Suppose if you take this is my master, this is my master, this is my boundary chip. The data is transferred. So this data transformation is nothing but what we call is peripheral. So this is my chip boundary or a processor boundary. The data is transmitted in what form? Peripheral part. The serial is nothing but data is transmitted in the serial manner. Peripheral means data is transmitted at the what? Chip boundary. So what is a serial and what is the parallel here? You know what is a serial data and what is meant by parallel data? What is serial data is? If there are in this room, when you are leaving, so if you go one by one, that is nothing but what? Serial. And what is mean by parallel? All the students will leave this room at the same time. Correct? That is nothing but what kind of what? Parallel operation. Did you understand? No, now you correlate. Reimagine this with the block, SPA block. Correct? So why we need a space when we have many other protocol like USB, PCI, DDR protocol, when need is for low cost, low power, not worried about the performance. Here, in this case, sensor is connected to the microcontroller. Performance is not a great matter for, correct? Because my data transmission will what? Low. I'll measure hourly, correct? So that performance is not a great important for me here. So if the performance is not the criteria, I can go for what protocol is. SPI. Did you understand? So the sensing the temperature in the electronic device. So sense once at a minute, how much data it will give? 1 byte. Let us consider if it is a 1 byte. So sensor needs to give 1 byte per the minute to the SPI protocol. Here for me, performance is not a matter. The data transmission is what? Very low. So that I can go with what protocol is nothing but SPI protocol instead of like going with what? USB or PCI or DDR protocols. Are you clear? So without SPI controller, is it microcontroller design becomes the complex? What I mean to say, without SPI controller, microcontroller design becomes complex since those components will have to handle the what SPI controller also wants. So that between microcontroller and the sensor devices, what comes here? SPI protocol. How do you understand? So without the SPI controller, microcontroller design becomes more complex. To avoid this, since these components will have to handle the SPI controller work also. So that SPI controller, so SPI master acts as an interface between the what? It is interface between the processor and the SPI slaves. If I'm talking about SPI slaves, many sensors are connected. One master is connecting it to the what? Many slaves. So there is some cases where many masters are connecting into the many slave sons. Do you understand? So what is the SPI controller? SPI controller acting as a SPI master. It is acting as a master. It acts as an interface between the what? Processor and the SPI. This is what I written here, right? This is my processor. So like this will be the slaves. Correct? Now this is the interface. interface between the what? Processor to the slave. So why we go for here in this case SPI interface? Serial parallel to serial and serial to parallel. Why specifically we go with low cost, low performance? So performance is not a what? I mean low cost, low power consumption, and then here data transmission is not a great priority for me, correct? Because I'm transmitting what? Low data rate, low data rate. I am not transmitting the what? Gigabits per second. So that I can go with what? In this case, I can go with what? Protocol is nothing but SPI protocol. So when I talk about SPI protocol, this is nothing but for me now, right now, it is nothing but a SPI master. SPI master. So SPI controller is SPI master acts as an interface between the processor and the SPI slaves. Whatever data comes from the SPI slaves, what is the data coming from the SPI slaves? For understanding, slaves we consider as what? Sensors. Let us take a temperature sensor or etc. SPI master collects this data and gives it to the what? Processor. So what data generally I'll be getting from the sensors? What data I'll be getting is serial data. That serial data will be converted into parallel and then that will be given to the what? Processor. So any information processor wants to send to the SPI slaves. Means what? Microcontroller to the what? Sensor. SPI slave. Processor first gives it to the what? SPI master. Then SPI master sends it to the what? SPI slave. Did you understand? What is the use of this SPI controller? It is an interface between your processor and the slaves. If anything, whatever data comes from the SPI slaves, like temperature sensor, like sensor data, etc., SPI master collects this, correct? And then this data is given to the what? Processor. Any information processor wants to send to the SPI slave, what it will do? Processor first gives to what? SPI master. And then SPI master sends this to what? SPI slave. This is what exactly I said. Very beginning of this one, analogy of this SPI interface. It collects the what? Parallel data. And it converts into the serial and gives to the slave. And if you want to send the data to the processor, it collects the serial data and gives to the parallel data the what? Processor and master. You need to understand now this is an interface between what? Your processor and the slaves. How do you understand this? Now, this is what exactly. SPI controller is nothing but what we have. There is a processor here. From processor to the SPI master. So what is the communication protocol is nothing but ADP, or it may be other protocols like AXI protocols, other protocols you can use. And this is nothing but exactly, we call it as SPI protocol. What is SPI protocol? SPI interface is nothing but this is the, we call it, this is the, correct? What it will do? It takes the processor, SPI master, what it will do? Take the data from the processor. That will be given to the what? Slave. If slave wants to give data to the processor, you take the serial data, correct? Give to the SPI master. That will be given to the processor. So this is what we are going to talk. This is nothing but your SPI interface. Are you understand? And processor slave will be having 4 signals. What are the 4 signals of the slave is nothing but slave SPI clock or slave clock we call S clock. And then MOSI is nothing but master output slave input. MISO is nothing but master input slave output. Master output slave input. This is nothing but S clock. And this is nothing but what? CS indicates here is nothing but, we call in analogy, we call it chip select or slave select. Correct. So in our case, we are talking about one master and multiple slaves. If I want to select the multiple slaves, what I want to go with? I want to go with like chip select. Selecting the first slave, selecting the second slave, selecting the third slave, so on. That defines this system. Are you understand? This is a master to the slave input, master input to the slave output. Then this is happening what? This clock, S clock. Or you can call this nothing but serial peripheral clock. You can understand, we will be talking about this one. Are you understand this? SPI controller. Now let us understand the timing diagram of this. Understand the timing diagram, SPI protocol timing diagram. SPI master, so this SPI master is reading the from where? Reading to what? SPI slave. Let us understand this first in this diagram. This is my master. This is my what? Slave. So this works on what class? S class. What is MOSI is nothing but master output, slave input. Correct. MISO is nothing but what? Master input and slave output. How do you understand? So here SPI master is reading what it is reading. This is my SPI master, right? SPI master is reading SPI slave at what? 0, this is nothing but hexa number, right? Hexadecimal number, 0, X53 address. Understand this analogy. SPI wants to read the data from where? From the slave. Master is reading the what? From the slave. Slave with the address of what? 053 address. Slave is giving what? Whether it is giving address or data. Data. So the data is giving is hexadecimal 46 data. Here, master is nothing but what here? SPI controller. Is nothing but SPI master core part is it? Master. Slave is nothing but what? Temperature sensor with the what? SPI interface. SPI interface. So what are the ports to the SPI is now? The ports to the SPI is nothing but there is a S clock, there is master output, slave input, there is a master input, slave input, slave output. What is CS is nothing but a chip select. There are multiple slaves are there. To this will be decided to which slave I need to select. You understand? So here MOS is nothing but master output, slave input. MISO is nothing but master input and slave output. Now you should understand the timing diagram. This is my S clock from the where it is. This is master. This is nothing but slave. This is a S clock from the master. Now you can see there is initially there is ideal. Okay. Then there is a what? Clocks are applied here. What clocks I am applying now? Master to the slave clocks. Then again there is a clock is gated here. And then again what happens here? Slave to the master. Again, ideal or next byte of data. Now clock goes in the gated form. Now what I am doing here? Master to the master output to the what? Slave input. So what I am doing in the master output to the slave input, what master is doing? It is reading. Read operation. Of what is the address of this read operation? Hexadecimal. So what is hexadecimal number is nothing but 53. So this is a data 8-bit data. That is 01010010. This is nothing but what? 53. Are you understand? This is a hexadecimal of 53. That is nothing but ASCII equivalent is nothing but what? This is. Now read is happening. This is master to the slave. It is giving the address. And then it is data. Master input, slave output is giving what? Data it is giving. What data it is giving? 0x46 in ASCII it is nothing but what? F. Are you understanding? First we should understand that how this MOSI, M by SO will work. This is my master and this is my slave. This is my clock from the master. From the clock from the master is giving the what? Address. Master is giving the address and slave is giving the what? data. You can understand? Now again, based upon this master output and slave input, the last bit, this bit will tells that whether you are doing the read operation and the write operation. This bit, the 7th bit will tells that what you are doing the write data or read data. So if this bit is 0, this will tells that what? Read data. This is what we are reading, right? I'm giving the address to the what? Slave. Then what I'm doing? I'm reading the address of that data will be what? Reading it. How do you understand this? If this last bit is 0, what I'm doing? Read operation. If this bit is 1, then it is a write operation. Did you understand these signals? What is SCLAR? What is MOSI? What is MISO? Are you clear this? Now let us understand the timing diagram observation. What is the observation of this timing diagram? What is the observation of this timing diagram is? Address is issued by what? Master. What is the address hexadecimal number we are giving is? 053. 0x53. Address is issued by the master to the what? Slave on what? Master output, slave input. And what is the other observation you can understand? Address or data are transmitted in the what? LSB first, LSB bit what? First manner. So what is the LSB bit first manner in this case is? This is 0, right? This is 0 and this is nothing but MSB bit. So this address and data are transmitted in the LSB bit first manner. This is my LSB bit 0 at the clock 0, clock 1, clock 2, clock 3 up to some clock 7. This is my what? MSB bit. And this is nothing, LSB bit, sorry. This is LSB bit and this is what? MSB bit. Are you understand? So address or data are transmitted in what manner it is? LSB bit first manner. So clock is gated. What is mean by clock is gated is nothing but whenever address and data are not what? Transmitted, the clock is gated here. This ideal state of this clock is nothing but we call it as a clock is gated. Clock may be gated to the 1 or it may be gated to the what? 0. So during this clock is gated when data and address and data are not transmitted here. Correct? You can observe this timing diagram. This is my clock. So what I'm doing? Address. This is address. This is nothing but what? Data. Master is giving what? Address to the slave. Slave is giving the what? Data. This is happening at what? Only when positive clock edges comes of the clock. Correct? When there is a no clock is gated means clock may be ideal here. Ideal means it may be the 1 or it may be the what? 0. When clock is ideal, that we call it as what? Clock is gated. So when address and data are not what? Transmitted. So last bit, what is the last bit is MSB bit of the address phase. Last bit of your MSB of the address phase indicate whether the master is doing what? Write operation or read operation. If my MSB bit is 1, what is the operation it is? Write operation. If MSB bit is 0, it is a read operation. You don't understand? Now, what other observation you can do in this timing diagram? The first observation you did that address is issued by what? MOSI. Master to the what? Slave. And then how address and data is transmitted means in the LSB first manner. And third observation is nothing but clock is gated. Clock is gated means when address and data are not transmitted. What is the other observation is? Last bit MSB of the address phase indicates whether the what? You are doing the write operation or read operation. Whether the master is doing write operation, then it is 1. MSB bit is 1. If it is read operation, MSB bit is 0. What other observation is? Master output and slave input and master input slave output. By default, it will be 1 if no information to be sent. You see, this is my what? Master output, slave input. This is nothing but what? Master input, slave output. When there is no data, correct? No information will be sent. It becomes what? 1, right? It is becomes 1 only. MOSI and MISO, it becomes 1 only. This is the fifth observation. And what is the next observation? Yes, clock is always driven by the what? Master to the what? Slave. Yes, clock is driven by the master to the slave. Both the master and slave should have a fixed delay. Fixed delay based pattern where they know when the write and read data phase should be started. What is mean by this fixed based delay pattern? It is. This is what operation I am doing here. It is write operation, read operation. Read operation. So here the clock is gated here. This is nothing but it is fixed here. Let us copy this.
मैं जा रहा हूँ खाना कुछ बनाने यार।
Let's copy this also. What is this? S clock is always driven by what? Master to the slave. And both master and slave should be fixed delay. Fixed delay based upon the what? Pattern. This is a pattern, correct? It should be maintained the what? Fixed delay. What happens if there is a clock, if there is no data, then there will be mismatch. Whenever you know that when you do the write operation, read operation, data phase should be what? Started date. So I need to maintain the what? Fixed delay pattern when you're doing the write operation and the what? Read operation. This is the sixth observation. The next observation is address and data are sampled. Happen at what age? This address and data should be happen at what age? Passage of the clock. Passage of the clock. Address and data must be transmitted without any breaks in the what? Pattern. So this is my pattern. There should be no breaks. There should be no breaks in the what? Pattern. That is another observation. No breaks means what? You are giving some data 110 and suddenly you give some zeros. Again you are giving 53. You are writing like 1100 and you will give some break. Again after that remaining bits you are start writing. That should not be maintained. So address and data must be transmitted without any breaks in the pattern. And then read to the slave at the address of what? Here, 53. And retaining the data of what? Address of this data is nothing but 46. Data will be read here. And here we'll be using the 7-bit address mode for the SPI connection. So why we'll be using the 7-bit address mode for the SPI connection? Out of 8 bits, this is 8 bits. Out of 8 bits, why we are using 7-bit address mode SPI connection? Because this last bit, correct? This last bit, MSB bit will defines for what? Write operation or read operation. So that's 7-bit address mode for SPI connection. So these are the common observation of the what? This timing diagram, SPI timing diagram. Did you understand? Let us show you. This is what operation this is. Now I'm writing this is S clock. This is ideal. And I'm applying the clocks here. Again ideal. Clock is gated here. Again I'm applying the what? Clock. So in this clock, what I'm doing? MOSI giving the what? Address. In this clock, what I'm doing? Data corresponding to the what? Address come through the what? MOSI. Correct. This is MOSI, sir. MOSI. Now this is the address I'm giving. I'm getting the what? Data, corresponding data to that address. This is nothing but what operation it is? Read operation. Now you can imagine the write operation. Side by side. Correct. This is my clock. S clock this is. This is S clock. When clock is ideal means what? Clock is gated. Clock gated means what? There is no read. There is no address and data should happen. Address or data should happen. Correct. When clock is what? Ideal. Or clock is gated. So this read and write should be happen always at the positive edge of the clock. That is the one observation we need. So this is what is the example? It is nothing but MOSI is giving the what? Address. This MSBBT is what? If it is 1, what it has to do? Write operation. I am doing the data write operation. Did you understand? The one we see earlier is what? Read operation. This is nothing but what? Write operation. You just again recall what are the observation we have done in these cases. You recall the observation because this observation is important to modeling this. What is the observation we did in these cases? What is observation? At least you can recall 5 observations.
Fixed delay.
Fixed delay. Okay, one is fixed delay. And second one is nothing but there is no breaking in the pattern. Correct. Second one. What is next one is? Clock is gated means there is no address and data transfer. Next is what? Address and data should be happen at what? Always positive. And what is next observation is? In this my pattern MSBBT is 1. Write operation. MSBBT is 0. Read operation. And there is no break in the pattern. And then we will be considering the 7 bits for the SPI interface connection. Why? Because this last bit is used for what? Read and write operation. Right? What other observation we did? In MOSI, MISO, it is a I. I when the clock is what? Gated or it is ideal. When clock is ideal, there is no what? Address or data transfer. Are you understand? So in the address, MSBBT is 1, then it is what operation is? Write transaction. In the address, MSBBT 0 is nothing but what? Read transaction. So these are the observations. These are the observations. First observation is address is issued by what? Master to the what? Slave 1, what signal it is? Master output, slave input signal. Correct. Address and data are transmitted in the what? LSB bit manner. LSB bit first manner. Clock is gated when the address and data are not transmitted. LSB bit is last bit. Last bit MSB of the address phase indicates whether the master is doing the what? Write operation or read operation. Master output, slave input, master input, slave output. By default, it will be 1 if there is no information to be what? Sent. And the S clock is always given by what? Master to the slave. Both master and slave should be fixed delay based on the pattern. Based on the pattern. So where they know when the read and write phase should be starting. Address and data sampling happens at the positive edge of the clock. And an address and data must be transmitted without what? Any breaks in the pattern. Read to the slave at the address of 53 and returns the data of what? 46. So we'll be using 7-bit address mode for the SPI connection. Need to understand this timing diagram of this one. This is SPI protocol timing diagram. So how many signals we'll be using for this is nothing but 4 signals. What are the 4 signals is nothing but S clock, MISO, MOSI, and one more signal we are using is nothing but port using nothing but CS or SS. CS is nothing but chip select. If there are multiple slaves on, so based upon the chip select, we'll be selecting the multiple slaves. I think, did you understand this timing diagram? And also we understand what is the observation of this timing diagram. Correct? Now we understand another port of the this SPI is nothing but what? Chip select. So SPI architecture supports one more master connecting to the one. Supports one more port. One master is connecting to the one. Multiple sleeves. Chip select is same as like what? If you remember in your P-select in the ABP protocol, what is the P-select is? Among multiple slaves, it has to select the one. Here it is same in India areas. The chip select is same as in what P-select in the ABP protocol. If there are 4 slaves are there, how you can select the 4 slaves? What is the correct way, legal way to give the chip selection is? So chip select is 1 not in. Chip select is 4-bit variable, 1 bit per one slave. So master wants to access the second. If master wants to access the second index value, what is the chip select value I can give? 40 to be 0100. This is for 0, this is for 1, this is for 2, and this is for 1, 3. So that second index slave, assuming index start from the 1, 0. So that if I want to select the second index, this is a chip select I can give. If I want to, master wants to access the third index slave, what is the 1 not encoding I can give is? Chip select is equal to 40 to be of 1. 1, 0, 0, 0. Did you understand? If I'm giving like this, 40 B of 1, 0, 0, 0, is it a legal way to selecting the chip slaves? No. Are you understand? What is the meaning of this chip select is nothing but among the slaves, I need to select the one. I can't select all the slaves at the same time. I should select the one. How I can select is nothing but using the chip select port. What is a chip select port is nothing but if there are 4 slaves are there, so chip select will be the 4-bit variable. So by using the 1 not encoding, master wants to access the second index slave. How to do it? How to do? What is the 1 not encoding I can use nothing but 0, 1, 0, 0. If I want to access the first 0, 0, 0, 1. If I want to access the second one 0, 0, 1, 0. This is nothing but 0, 1, 2, 3 means 4. If I want to access the first one, 0th index will be 1 and remaining will be 1, 0s. Correct. So if not permitted to have the multiple slaves selected at the one same time, if my chip select is 40 to be of 1100, it is not possible, right? There is nothing but any pattern with more than 1 bit high is not possible to select the slave. In any protocol, however we get the term chip select is nothing but it always means one master is connecting into the one multiple slaves. What is in any protocol? Whenever you get the term chip select is nothing but it always means that one master is connecting into the multiple slaves. Chip select helps to decide which chip means slave is selected among the one connected slaves. Now you can see this is my master. This is a master, SPI master. These are the slaves. How many slaves are there? 3 slaves are there. S clock is connecting into the one. S clock is driven from the master to the slave. S clock is connecting into the all the slaves. And then master output, slave input is also connecting into the one. All the slaves. Again, master input, slave out is connecting from where to? Slave to the master. Then what is this? SS1 is nothing. SS means slave select 1. This is select a slave 1. This is slave 2. And this is nothing but what? Slave 3. Or you can write a chip select also. Select 1, select 2, and select T. Select 3. Did you understand here? What is one more port of this? Chip in the SPI is nothing but what? Chip select. Now we'll understand what is SPI master is. What is the SPA master. What is SPA master is? SPA master is an interface with the what? Processor on the one side of the what? SPA slave. My SPA master is an interface with the what? Processor on one side and SPA slave on the other side. Means example, temperature sensor, humidity sensor on the one other side. Processor gives the information to the what? SPI controller by programming it what? By programming its registers. So generally we'll be using 3 registers in SPI. Processor will give the information to the what? SPI controller by programming what? Its registers. What are its registers? One is address register, one is data register. One more important register is nothing but control register. Control register. I understand. Processor gives the information to the SPI controller by programming its what? Register. The registers are like control register, correct? This is what. If I talk about this one, you can see this one. This is my what? SPI controller interface. In SPI control interface, my processor will use what? It is programming the what? Registers. What registers is nothing but SPI registers like address register, data register, control registers. So this is nothing but my SPI master. Correct? What is SPI master is? SPI master or we call SPI controller also. So this is the interface between what? Your processor to the slaves. Slaves like what? Temperature sensor, humidity sensor, etc. So what is the signals between your SPA master to the slave is? What are the ports we talked about? S clock, master output, slave input, master input, slave output. What is this nothing but? Chip select or slave select. These are the ports of the what you are. My SPA interface. Are you understand? Now this processor is modeling the what? Programming the registers, SPI registers. What are the registers is nothing but address register, data register and control register. First we'll understand all this. What is address register? What is data register? What is the control register? You understand? For this we'll be using one clock is nothing but what? S clock reference. Processor to the what? SPI master. So we'll be using one clock is nothing but what? S clock reference clock. But your SPI master to the slave is what clock it is? S clock it is. How do you understand? Is it clear? Now let us understand. First understand what is a master, SPI master or SPI controller. So SPI master interface with the processor on one side and SPI slave on the other side. Example like temperature sensor, humidity sensor on the other side. Processor gives the information to the SPI controller by programming the what? Its register. Now we need to programming what? Registers. So SPI controller gets the processor transaction in the form of what? AVP transactions. These transactions return the what? Registers in the SPI controller. Or you understand this definition, this point? Processor gives the information to the what? SPI controller by programming its register. SPI controller gets the what? Processor transactions in the form of what? AVP transactions. These transactions write the register into the what? SPI controller. SPI controller use these register values to drive the SPI interface signals in the what? In the what form it is? SPI transaction format. This SPI slave can understand the above transaction since it is coming from the where? SPI format. See this point, whatever I'm talking about here. Let us see this point. My SPI controller, if processor gives the information to the SPI controller, how it will give? It should program in the register. What are the registers? Address register, data register, and control register. SPI controller gets the processor transaction. Transaction means what? Read data or write data. In the form of what? AVP transactions. These transactions write the register into the what? SPI controller. What SPI controller will do? SPI controller uses these register values to drive the SPI interface signals to what? SPI transaction in the SPI transaction format. SPI slave can understand the above transaction since it is coming from the where? SPI format. So we can't directly connect SPI with the what? Processor. The transaction cannot understand. Slave and processor will not understand. So that SPI will come what? As an interface here. It will get the what? Transaction from the what? Processor. It will make according to the what? SPI. It make the format of according to the what? SPI controller. That format should be understandable by what? Slave. Did you understand this? The point is that, okay, this is my processor. Okay. This is my SPI controller, SPI master. This is my what? Slave. This is a slave. This is the processor. This is a what? SPI controller or a master. SPI master. We know that slave is directly can't give transaction to the what? Master. Processor. Sorry, processor, or I can call it for a master. In general, it is a master. Now, what it will do is nothing but processor will do the programming for the what? Register. Using what? Using AVP. What register it will do means address register, data register, and the control register. Control register. This is what I said. First, processor gives the information to the SPI controller by what? Programming its register. Now it is going to programming this register. For this, we need a reference clock. That clock is nothing but we are taking as S clock reference. Do you understand? Now, SPI controller gets the what? It gets the transaction in the form of what? AVP transaction, correct? This SPI controller gets the transactions in the form of what? AVP transaction. So these transactions write into the what? Register in the what? It is right into the register of what? SPI controller. Correct. The SPI controller uses the what? Uses this register values. Uses this register values to drive the what? To drive the SPI interface signals in the what format? It's a SPI transaction form. You can understand. Now, the slave can understand these transactions. Correct? If this transaction, if directly if I'm going to the slave, it does not understand. Now, what we will do using processor will be modeling the what? Programming the register transactions through the AVP, and this will be right into the what? This register transactions will be right into the registers, and this SPI controller it makes it what? SPI format of SPI transaction format. Now this will be understanding by the what? Slave. That is what these 3 points here. This point, this point, this point. Now slave can understand about the transaction since it is coming from the where? SPI format. Are you understand this? In summary, for this summary, SPI control is converting the what? It is converting the AVP transaction coming from the where? Processor into the what? SPA protocol format, and it will also do the vice versa. Correct? Means what are the transactions coming from the ABP? It is getting from the processor. It is making into the what format? SPA format. That will be given to the slave. Slave can understand the what? SPA format. And it also do the vice versa also, right? Now it will get the slave format. It is making into the what format? SBA format, transaction format. That should be understood by what? Processor. In general, I said that in the beginning, it is what? Processor is a parallel data, converted into serial. That is what? SPA job is nothing but it is making the SPA format to make the understanding the processor, to make the format to understanding to the what? Slave and do the vice versa job. In general, correct? This is a summary. SPA control is converting the ABP transaction coming from the processor into the SPA protocol format and do the vice versa. So SPA control is acting like a what it is. It is an intermediate component between the what? Processor and SPA slave communication. Now with this you are understanding what is the role of SPA. Can you recall what is the role of the SPA? Correct? It is an intermediate between the what? Your processor and SPA having its their own protocol to set up the SPA transaction format. That should be understanding by what? Processor. And also that format will be understanding by what? My slave. And also do the what? Vice versa. Is it clear? So processor can't directly communicate with the what? SPA slaves since it does not have a what? SPA interface. Did you understand this? What is meant by SPA master or SPA controller? Now we'll go into the what? SPA controller. Overview of the SPA controller. The SPA controller, how many interfaces we have? What are the interfaces to the SPA controllers? SPA controller interfaces with the what? Processor using what? ABP interface. And it interfaces with the what? SPA slave using what interface? SPA interface. Now for the SPA controller, how many interfaces? Two interfaces now. One interface is nothing but what? With the processor using ABP interface and interface with the what? SPA slave with the SPA interface. So what is ABP interface? What is the ABP interface is used by the processor to program the what? Address and data registers and also the what? Control registers. Address and data registers act like a what here it is? Like it's like a buffer. Buffer means what? Storage element. Similarly, like it is like a what? FIFO is nothing but what? Storage, right? Buffer. First in, first out operation. Are you understand? Or it is same as in what? FIFO in what? Parallel input and serial out. Did you understand what is this ABP interface is? ABP will do what data? Parallel data. Parallel to what data? Serial data. So this ABP interface used by the processor to program the what registers? Address register, data registers. Address and data registers act like a buffer similar to FIFO in the what? Parallel input and serial output format. What is SPA interface? What is SPA interface? It is used to drive the above address and data into the what? Serial manner to the slave. Correct. If you are talking about master to the slave, what is the job of your SPA interfaces? Used to drive the what? Above address and data in what format? Serial format. Serial manner. So SPA controller as a what? Also here one more register we call it as what? Control register. What is this control register is? Two registers we talk about. One is address register, one is what? Data register. So one more is what? Control register. What is control register is?
From my daughter's question, it says. Compare section plus something.
SPA controller having one more register is control register. This register has to be enabled bit. It is acting as an enable bit. What is the use of this control register is whenever this enable bit is programmed to 1, SPA controller initiate a write or read to the what? SPA slave. Example, slave is nothing but sensor. So we program this register with enable is equal to 1 once every minute so that the sensor reads will happen to the every minute. So data comes from the SPA master from the sensor. Processor will read this data and display it to the what? Display board. To understand this, what is the use of this control register is this register as acting as a like what? Enable bit. Whenever this enable bit is programmed to the 1, SPA controller initiates what? Read or write or read to the what? SPA slave. When we program this register with enable is equal to 1 once every minute so that the sensor reads will happen for the every minute. So data comes to the SPA master from the sensor and processor will read this data and display it to the what? Display board. Did you understand? So the use of this, okay, let me show you. What is the use of this control register is? This is your control register. This is my control register. The control register is what? This is a 8-bit control register. This bit will says what? What this bit will says? In the control bit, this bit, if this is 1, what it says? Start or stop the transaction. If it is enabled, this bit is enabled, means 1. Disabled means what? 0. Control register is 1 is nothing but you can start. Control register of 0 means what? You can stop. This bit will test this bit. That is what I am talking about here. Look at this. The control register has enable bit. Whenever this enable bit is programmed to the 1, SPA controller initiate the write or read operation. Write or read to the what? SPA slave. Means we program this register when enable is equal to 1 once every minute so that sensor reads will happen every minute and data comes to the what? SPA master from the sensor. Processor will read this data and display to the what? Display when this is enabled. Okay. And other SPA controller is nothing but if you look at the other use of this control register is so this 3 bits. This 3 bits is used for how many transactions do we need to do? How many transactions we need to do? So how you can do this is nothing but if this is 1 and this is 1 and this is 1, these 3 bits are 1, 1, 1. How many transactions will happen? All these 3 down to 1 is nothing but. So this 3 bits tells that if this is 1, 1, 1, how many transactions do we need to do? Means if this is 1, 1, 1, how many transactions will happen?
7.
It will happen the number of transactions is equal to the control register of what? 3 down to 1. 3 down to 1 plus 1. If this is 1, 1, 1, how many transactions will happen? This is 1, 1, 1 plus 1 is nothing but 1. 8 transactions will happen. Need to happen. We need to So this is nothing but how many transactions do we need to do? How many transactions we need to do will be controlled by this one, control register of this 3 down to 1 bits. If this is 0, 0, 1, how many transactions do we need to do? 2. This is 0, 0, 1 means what? 1 plus 1, 2 transactions. If it is 1, 1, 1 means what? 7 plus 1 is 8 transactions. If it is 6 means what? 7 transactions. These 3 bits of your control register will be using for what? How many transactions do we need to do? First, we will understand this control register completely. What is the first bit will tell? 0 bit will tell whether I need to start or stop. If it is enabled, is what? Read or write. Correct. And if enable is equal to 0 means what? Stop. No read or write. And these 3 bits are used for what? How many transactions do we need to do? Plus 1. Correct. This bits plus 1 is nothing but what? That gives the how many transactions do we need to do. And what is these 3 bits? 6, 5, 4. From which transaction do we need to start? From the which transaction do we need to start? So example, 6 down to 4 is 0, 0, 0. We need to start from what? 0, and we need to do what for how many transactions? 8 transactions. If my this 3 bits, 3 to 1 is nothing but 1, 1, 1, 1, 1, 1. This bits will tell us that if this is 0, this is 0, and this is 0, tells that from which transaction do we need to start. So example is 6 down to 4 is nothing but 0, 0, 0. We need to start from where? 0. 0, and we need to do how many transactions? 8 transactions. If it is 0, 0, 1, from 1, we need to start. If it is 2, from 2 to we need to start. So these 3 bits is what? From which transaction do we need to start? And what is this last bit is used for? It is used to tell that transaction is what? Completed. Same bit is also used for raising the interrupts. Okay, you don't take this one, last one. This last bit is used for what? It is used to tell that whether transaction is completed or not. The control register is how many bits it is? How many bit register? 8 bit register. What this control register will tell us? What are the operations? Start, completed. Then how many transactions I want to do? Then from which transaction I need to start? Did you understand? So that will be decided by what? Control register. What is the use of the address register? What is the use of the address register? Address register is nothing but what? It is locating the addresses of the what? Data. So data register will be having a data in the data register. So now we understand about what is the control register. Now again coming back to this, what external blocks does SBI controller interfaces with? We understand this one. Which one is? What is the SBI master controller? What this SBI master controller will do? So this is what, in summary, SBI controller will do, converting the ABB transaction into the what? In the form of what? SBI protocol format and vice versa. This is what we'll do. And then this SBI controller will be having how many interfaces? 2 interfaces. One is ABB interface with the processor. ABB is nothing but with the processor is ABB interface with the what? Slave using what? SBI interface. Now coming to this. What external blocks does SBI controller interfaces with? What are the external blocks SBI controller interfaces with? One side with the what? Processor. Other side with the what? SBI slave. So program the what one side processor will do? What is the job of the processor? Program the what? What we need to program? program the address and the what? Data registers. Then what we need to program? Program the control register. This is from the what side? Processor side. From other side is nothing but what? SPI slave side. What we need to do? SPI controller issues the what? Address, write or read information to the what? SPI slave in the what manner? Serial manner. SPI slave will either capture the what? Write data, or it will provide the what? Read data to the what? SPI control. This is the one side part of the program we need to do. The another side of the part of the program is what? This is the one. Other side of the SPI. Other side is nothing but SPI slave. SPI controller issues the address, correct? And also issues the what? Write and read information to the SPI slave in the serial manner. SPI slave will either be capturing the right data, or it will provide the what? Read data. This is what we are going to programming for the SPI controller. You understand this? So now, similar to the SPI controller, for every peripheral protocol, corresponding to the controller is required so that peripheral can be interfaced with the what? Processors. Example, like if you talk about USB 2.0 pen drive requires what? Controller. USB 2.0 controller. If you talk about PCI device requires what? PCI controller. Today's SD card requires what? SD card controller. Did you understand? Did you understand this point what I'm talking about? It is like taking the transaction from the processor, converting it into one SPI transaction format. That should be understood by the what? Slave. It is a kind of converting the parallel data into the what? Serial data. If you do vice versa, take the data from the slave serial data, convert this into the what? Parallel data. So that this is like acting like an interface. The transactions coming from the EVP is making into the format of what format? SPI interface format. That format should be understood by the slave. Is it clear? Now, like this is one example. Sensor to the microcontroller connection, I need a what? SPI controller. Like that, if I want to do the pen drive, USB pen drive, what controller I need requires for this is nothing but like USB controller. If I'm doing PCI device requires what? PCI controller. If I do SD card requires what? SD card controller. Did you understand this? So this SPI controller detailed functionality is processor programs the what? Registers. Address register, data register, and control register. Processor configures the what? Control register in the way SPI controller. And to trigger the transfer and to indicate how many transfer need to do. And SPI controller architecture. So we saw in the above slide, this is architecture. This is architecture of the one SPI controller. We have a processor, then this is a APP transaction to the what? SPI controller or SPI master. This makes into the one SPI format. This should be understood by the one slave. So SPI controller interfaces is what? Processor. AVP can be what? Other interface also. It may be you can use AVP or other interfaces. We go for the AVP interface. And another side is nothing but SPI slave. What are the ports to this is nothing but S-class. What? Master output, slave input, chip select, master input, slave. So these are the ports to the one SPI slave. From where to where it is? These ports are from where to where? Master, SPI master, or SPI controller, or SPI interfaces to the what? Slave. You can understand. So this already we studied about, right? What is the use of SPI system architecture? Then what is the use of this chip select? You can understand. Now this diagram also we saw about the SPI controller. This is a complete architecture of the what? SPI controller. This is what we are going to interface. Correct. This is the interface, SPA interfaces. So in SPA master, programming the register is done by what? How you are programming the register in the SPA is done by the SPA processor by using AVP protocol. Correct. From interfacing from master, SPA master to the slave, we go for these signals. What are signals is? This clock, master slave, master output slave input, master input slave output, and the chip select. So first what we'll do, we'll do this part of program. What we need to do first? Programming the what? Registers in the way SPA master. Programming the register in the SPA master. After programming this, then we go for what? Slave. You understand? This part of almost we done this part of this one, right? How to programming the register is. How to programming the register. This is the kind of what? Memory modeling. Memory modeling. Okay. So once we do this, then we go for what? SPA controller. This SPA controller interface, we can make this into the what? States. Make them into the what? States. How many states are required? We'll represent the states. Then we'll program for what? This state. Exactly how you done in the what? Interrupt controller. You are modeling the memory using what? AVP. Priority register is modeled using what? AVP. Then now this interrupt controller collect the interrupts giving to the what? Processor and to be served and waiting for the what? Service. That we have done with what? State diagram. Right? Here also the SPA controller operation will be done through what? State diagram. How do you understand? Today let us understand how to model the what? How to programming the register. What are the register we need to program? Data register, control register, then address register. Address register, data register, and control register. Now, can you imagine what are the input signals to the AVP protocol? What are the input signals we talk about? Common signals are what? P clock, P reset. Then data signals are what? P address, PW data, P write data. What are the control signals are? P enable, P read, P write. P write. So we drop the P select and then P error write. We don't want to make more complex programming. So that P select and P error will be dropped. So these are the signals. Same signals will be. How do you understand? Then we need to program for the what? First we need to program for the register. Address register. Then we need to program for the what? Data register. Then we need to program for what? Control register. How do you understand? Now let us go through this. So what I can do today, let us briefly explain you how to model Just I will explain through the program. Next class we will write a program. Line by line we will write the program. Correct. Now you understand that what I need to do first is programming the register. Programming the register is done through what? AVP. What are the signals to the AVP is nothing but P clock, P reset, P enable, P address, PW data, correct? P write data, P read data, and P write. What this P write indicates here? Write the data when it is 1. When it is 0, read the data, right? When to do the transaction? When to do handshaking is? Enable is equal to 1, ready is equal to 1. Ready is equal to 1. So these are the signals of the what? AVP. Then you also see what is the signals or ports of the what? SPA. What are the SPA? From master to the SPA, master to the SPA slave. What are the ports are? S clock. S clock, correct? S clock we are using, then what we are using? Master output, slave input. This is nothing but what? Master input, slave output. This is nothing but what? Chip select. So S clock is the input or output. Where it is driving from? Master to the slave. So going outside means what? Output. Master input, slave output is what? From master to the slave. Output or input? Master output, slave input. It is going from where to where? Master to the slave, right? It is output. What about this one? Master input and slave output is from where to where? Slave to the master is nothing but what? Input. And then the control signal is the output. So underscore I underscore O indicates that outputs and the input. So these are the ports of what? These are the ports of the ABP and these are ports of the SPA. How do you understand this? Now, what we need to do? We need to declare the parameters. So what parameter is required here? We need a parameters like how many transactions we need to do. So this will understand when you go for the SPA data. Okay, how many transactions? What is the width of that? Okay. And then this is also parameters I'm declaring for the what? These are parameters you're declaring for what? States. States of what? SPA. These are states of the SPA. Okay, we'll understand this later. First, we'll do programming the what? Registers. To do programming of the register, input is nothing but what? What are the inputs? Clock is the input, reset is the input, enable is the input, then P address is nothing but what? Input with the vector, and P W data is nothing but what? Input with the vector, and P rate is the input. Okay, so you can skip the signals or outputs of the what? SPA right now. So we'll understand how to modeling the register, AVP registers. This is a signal of what? SPA. This is a signal of what? SPA reference class. Correct input. And then P R data is input or output? Output with the vector. So width I'm taking is 8. So 8 minus 1 is nothing but 7 down to 0. So P ready is output. S clock is output. MOSI is output. And then how many slaves I'm selecting is nothing but here. 3 down to 0 means it is depending upon the number of slaves. If 4 slaves are there, it is what? 3 down to 0. Chip select is the output. Did you understand? Now, to model the register, what are the registers are there? Address register, data register, then what? Control register. So what is address register? It is depending upon the maximum number of transactions. How many transactions I want to do. This gives the depth, right? This is nothing but memory modeling. Array of vector, memory modeling. This is the depth and this gives what? Width. Again, the same data is nothing but what? Depth and then what? Width. Then this is for what? Control register. Control register with the vector. Now we'll go for how to register for the. This is for register for the what? SPA. So we'll take this later. All these signals we'll take it later. Now we'll concentrate on how to programming the SPA register. We need to program the what register is. SPA register like address, data and control register. So I'll start with always at the positive edge of the clock. If reset is equal to 1, what I need to do? All the X data types to what? Making to zeros. So here P R data is 0. Then P ready is 0. Also, I'm making the SPA ports also. This is making to 1. I will tell you when you talk about SPA interface. And then this control, initially it will be selecting what? 0, 0, 1 means what? This is 3 down to or 2 down to 0 it is. This 3 down to 0 means I need to take it is a 4 bit 0, 0, 0, 1. Let us talk about these signals later. Then what I need to do? I need to do the for loop to making this memory to what? This is like a memory, right? Address register and data register is depth and the width I have. So this I'm making 0 and this I'm making 0. Then what other things I need to do? All these signals are relating to the what? State machine and the SPA interface. Is it clear? Now, how to model the register? If reset is equal to 1, I'm making all this read data, correct? Already, R data, already, and then my registers, address register and data registers, I'm making 0, 0. Correct. Then now I need to model this. I need to model this register. How to do this? Else block tells what? My reset is equal to what? 0. If enable is equal to 1, ready is equal to 1. If what? Write enable is equal to 1. What I want to do? I want to do write. How many writes I want to do is nothing but I'm considering the 8 bits. 8-bit SPA. Okay. So I need to write from where to where? 0 to 0, 0 to what? 0, 7. So address of this, address of register A of P address is equal to what I want to do. Write that in. And then add if my address is greater than 10 to 17. Why it is 10 to 70 is, let us take this. Let us take this. This is my address register. This is my data register. This is my control register. Control register. So control register is 8-bit. Address register and data register, what we have? Depth and what? Width. Depth and the width we have. So address register I'm taking is 0 to 8, means what? 0 to 15. So from 8 to 15, I'm going to reserve this. I'm reserving this. So even in the data register also, after this, if what is the next is nothing but 10, right? 1, 0. 16 is nothing but 1, 0. 1, 1 up to 7, what? 118, 1, 7. From 180 to the 1F is nothing but what I'm doing here. I reserve this. Further, if I increase the bits, so that I am reserving these bits and these bits. So you can see in this program, my address from where to where? P address is coming from where to where? 0, 0 to what? Logical AND operation of what? 0, 7. The address register A of address, what I'm doing? I'm writing the data. And similarly for address is what? Greater than or equal to what? 10 to what? 17. Means this is the one. 10 to 17. 10 to 17. What I'm doing is all data and data register. What is data register? Is nothing but address of -8 is equal to what I'm doing is nothing but write data I'm doing. This is for register modeling. This is for what? This is the address data. This is nothing but what? Data register. This is address register and this is data register. And then next day what I need to model is control register. Control register is nothing but operands. So this is 0 to, this is 10 to 17. Remaining bits are what? Kept for the reserved bits. And then after 1F, what I'll get? 20. 20. So this is 20. If my address is what? 8-bit of 20, then I'm doing what? Control register is equal to what? Write data. Did you understand? So this is how you can program the for what? Program register. When this will happens, if P enable is equal to 1, and then P ready is equal to 1. If write is equal to 1, I'm doing this. We are writing the data to the what registers? Address register, data register, and the control register. If this enable, this P write is equal to 0, what I want to do? Read the data. Read the data to the what? Address register, data register, and control register. Did you understand? So this is how I can program the for programming the register from the processor. Did you understand? Now other part of program is nothing but this is the one for the SPA. So for this we need to understand the state diagram of this SPI protocol. So today what you can do, you understand what is SPI, what are the signals of the ABP, what are the signals of SPI interface. Correct. You understand that how to model the programming the register to the from the processor, from the ABP. You understand this and this part of program. So we'll talk about in the next session. You understand? So what are the signals we have from the SPI interface? Four interfaces, 4 ports. What are the 4 ports? S class, master output, slave input, master input, slave output, then chip select. Correct? What are the ports for the ABP? Already we deal about that, right? Common signals are clock and reset. Then we have data signals like address, write data, read data, control signals like what? Enable, ready, and then run. You don't understand. So all about this SPI protocol, SPI interface is nothing but this is a one. So we are just now we saw that how to do this, right? From the what? ABP. Now we should concentrate on how to do this. Is it clear? SPI interface. We need to do the program. Did you understand? Now, can you analyze again what is the SPI controller here? What is the SPI controller? The interface between the processor and the SPI slave. It will take the what transactions? It will take the ABP transactions. It is making into the what format? SPI transaction format. This format will be understood by what? SPI slave. And also it does the vice versa also. It will do the vice versa. It will take the slave transactions, make this into the what? According to the SPI transaction format, that should be understood by what? Processor. It is something like converting your parallel data to the what? Serial data. And serial data to the what? Parallel data. So directly I can't connect the slave to the what? Processor. So that I need an interface to address this issue. Very clear. So let us understand all this. What are the signals we are using for the SPI interface and also for the ABP interface. We will do the programming. We'll understand the timing state diagram of how to do this part, and we'll write a program and then we'll generate a test bench to this. Correct? So what are the observations you should make for during the write operation and read operation? What are the observation? What are the observation you should make? To model this SPI, this timing diagram is quite important. Correct. This is why what master it is. SPI master or SPI controller. Correct. To the what? Slave. Then one more signal is nothing but what? Chip selector. Chip select. What observation you need to do? This is a clock is from where to where it is driving. S clock is driving from the master to the slave. Correct. When clock makes ideal indicates what it is. This is nothing but a clock gated. Clock gated means what? Ideal state means there is no address and data transfer. Correct. And then what other observation? The address and data will happen to the what? Passage. And there will be no break between the what pattern. It is a pattern. What pattern is 53 is a pattern. There is no break between the pattern. And then what is another observation? MSBPT is for representing the what? Read operation and write operation. Correct. Read operation and write operation. Then when the clock is gated, your MOSI, MISO is nothing but what? 1. And you should maintain the what? Fixed delay between the what? address and the data. Address and data transfer, correct? Next, what are other observation is? For the SPA connection, so we'll be taking how many bits? 7 bits. Only 7 bits will consider. Last bit is indicating for read or write operation. Next, what is the next other observation in these cases? What is the other observation? So when the clock is gated, correct, there is no address and data transfer. So these are the observations. So using this is what we are going to do the programming for the SP. So before that, we'll do what? Register modeling. Register modeling through ABT. Is it clear? So in the next session, we'll be going with this. Okay. So tomorrow there will be a break, and then day after tomorrow, system Verilog demo session will start. So this session, whatever the pending in the SPI, in the next week, in the afternoon, parallelly system Verilog sessions will be go on. In the meantime of the afternoon, I'll be take up the session and I'll complete the SPI protocol, SPI interface. Okay. So there is a break tomorrow, and day after tomorrow, Verilog, system Verilog demo session will start, and from Monday, system Verilog will go. And I'll make a time, and then I'll take the sessions, and I'll complete this SPI interface protocol. You don't understand? Yes. So any questions from your side regarding the critical part about this? Programming will do. Okay. Programming will do, or design file for SPI, I'll teach you how to do. Regarding theoretical part, any questions are there? Sir. Let's stop the session here. So we'll continue in the next session.